So, last class I have covered approximate stress distribution method for loaded areas, because earlier we have covered what is the stress distribution because of point load, line load, strip load, circular loaded area, rectangular loaded area. Now, if you want to find it out very quickly, what should be the method? This is the approximate method has been proposed, and it is by means of 2:1 method. So, 2:1 method means 2 vertical and 1 horizontal. Based on that, for rectangular loaded area and for square, safe, for strip footing I have covered. Then equivalent point method means divide the loaded area into small areas. If there is area B by L into small areas, then replacing the distributed load on each small area, and then replace the distributed load on each small area by an equivalent point load, which will act at the CG of the area. So, this is your CG. So, equivalent point load act at the CG of the area, then sigma z is equal to, it is a summation of q1 I1 q2 I2 dot dot qn In divided by z square. So, based on that I have started one example how to solve it. Suppose this is the case, rectangular loaded area. First, point load may be anywhere else, point where your stress you need to find it out. Second, it may be outside the area. Third, it may be one of the face, either B or L it will be there. So, first one I have covered. Go to the second one, case 2. So, what will happen? So, there is a point somewhere else at point O. Then in this case it is not equal. First principle is I have to divide in such a way that it should be at the corner of your rectangular loaded area. That means at the corner means if I divide it in such a way that the point O should be common corner. So, this is the case. If I say this is my A, this is B, this is C and this is D, if I make it, it will be E, F, G, H. So, if you look at here, I make the area in such a way that this rectangular it is at this point, this is your corner. Similarly, this rectangular, this is also corner, this rectangular, this point is corner. So, this rectangular, this point is at the corner. Then in this case sigma z is equal to q into In1 plus In2 plus In3 plus In4. If q is not equal, if it is something else, then you can make it different q1 I1n, q2 In2, q3 In3, q4 In4. Now, go to the third one, third case. Look at here. This is your rectangular loaded area and this will be A, B, C and D. With this, this is originally, this is my area. So, this will be for A, B, CD, and it has been asked some point O which outside your rectangular area. Find it out stress because of a rectangular loaded area at point O which is outside this area. Now, what is supposed to be done? So, basically I will make in such a way that I just expand it in this way, so that it become, I just added areas, rectangular areas, so that it will be becoming a corner. Now, if I put it, this is my 1, this is 2, this is 3 and this will be 4. Now, if I take it 1, or if I can write it because of the area, first make it area A, B, C, D, then it will be area E, O, F, then here it is G, H. So, this will be area A, E, O, F, A, E, O, F. I have taken complete A, E, O, F, first one, then minus, because our interest is because of this loaded area and at this point increase in stress, minus area B, E, O, H, minus area B, E, O, H, right. Then because this has to be neglected, if this is the total area, this has to be neglected, then this strip has to be neglected. What happened? This is the point O outside the area, I make it, extend it, so that this is the total rectangular area, this is at the corner, then out of which this rectangle I will make it out. So, again this is at the corner, then out of which this rectangle I will make it out, then again it is at the corner, then this is the part which has been come twice, then it will be added. So, minus D, G, O, F, then plus C, G, C, G, minus D, G, O, F, minus D, G, O, F, plus C, G, C, G, O, H. You have taken this complete area, deducted from here once, deducted from here once, because this area is superimposed of both these areas. So, then it has been deducted twice, then you have to add it into once. So, then what will happen? It will happen Q into IN 1 minus IN 2 minus IN 3 plus IN 4. Then come to your case 4. Case 4 is this is the area, and in this area it has been asked to find it out increase in stress at this point. Suppose this is my P. So, this will be A, B, C and D. What I am supposed to do? This area should be corner, then I divide it into very simple way, 2 rectangles. So, for this rectangle this point is at corner, for this rectangle this point is at the corner. Then what will happen? Sigma n is equal to Q into IN 1 plus IN 2. This is 1 and this is your 2. Let us solve one problem, one or two examples. Let us solve it, how it looks like, then we can see it. Example 1, one L-shaped building in plane exert a pressure on the building 75 kilonewton per meter square on the soil. Determine the vertical stress of the element at a point 5 meter, Z is equal to at a point 5 meter below the ground surface at point P. Look at the what is the shape has been given, the dimensions has been given. This point is your P, this dimension is given 10 meter and this dimension is given 15 meter, sorry by drawing it is small, but this is your 15 meter, this is your 10 meter, this is your 20 meter, and if I make it, this will be my A1, this will be my A2 and this will be my A3. So, it has been divided into 3 small parts. So, then delta sigma will be Q IN1 plus IN2 plus IN3, IN1 plus IN2 plus IN3, IN1 plus IN2 IN3 why? A1, this is your corner, this is your corner, this is your corner, this is a very straightforward. For A1, M is equal to N, which is equal to 10 by 5. 10 by 5 means this is your size, L is your 10, 5 is your below the depth, Z is equal to 5, B is equal to 10. So, this will be your 2.0 and IN1 is equal to 0.2325. For A2, M is equal to 15 by 5 which is equal to 3, 15 by 5 3, N is equal to 10 by 5 which is equal to 2. So, based on M and N, if you come back here, based on M and N you can find it out directly I by using this formula. Then either you can use this formula, then find it out from the chart, it will be 0.2378. Then A3 is equal to M is equal to 20 by 5 which is equal to 4, N is equal to 15 by 5 which is equal to 3, then IN3 is equal to 0.2450. So, sigma z or delta sigma z is equal to, what is the value of the Qn? Value of the Qn, pressure intensity is given 75 kilonewton per meter square. So, it will be 75 kilonewton per meter square because it is throughout, here it is 75, here it is 75, here it is 75. If it is varying, then you can take the varying. So, 75 into IN1 is your 0.2325 plus IN2 is your 0.2378 plus IN3 is your 0.2450 which is equal to 53.65 kilonewton per meter square. Now, come to example 2. There is a case in this case point P will be located it has been asked to find it out increase in stress because of a rectangular loaded this at here outside your loaded area at point P. So, as I said, I have make it in this arrangement. So, let us name it A, B, C, D, then E, F, P, H, G. Now, let us put these dimensions. This is your 0.5 meter, this is your 2 meter, and this is your 2.5 meter, and this is your 1.0 meter. And load intensity Q is given 80 kilonewton per meter square, and Z is given 2.5 meter. What is the Z? If this is my surface, in this ground surface, it has been asked at a distance Z is equal to 2.5 meter below, find it out increase in stress. Now, let us write it. Delta sigma Z is equal to Q into IN1 minus IN2 minus IN3 plus IN4. IN1, IN2, IN3, IN4, if I put it 1, 2, then 3, and this will be my 4. Why it is added IN4? Because while doing this IN3 and IN2, this part has been added, subtracted twice. So, hence IN4 has been added. Now, let us find it out M and N for A1 or for 1 loaded area here. So, this will be a complete. What is your completing? IN is for 1, IN is completing 1 means this is your A, E, P, G, A, E, P, G entire area. So, in this case M is equal to, what is the length? 2.5 plus 1, 3.5. It is your 3.5 by 2.5, it is your 1.4. N is equal to 2 plus 0.5, 2.5 by 2.5, which is equal to 1.0. So, IN1 from that formula or chart, it comes out to be 0.1914. First one is over, this is what is your IN1. Then second one is your, if you look at second one, that is your rectangle BGFP. In this case, M is equal to 2.5 plus 1, 3.5, 3.5 by 2.5, which is equal to 1.4. N is equal to your 0.5, this part is your 0.5, 0.5 by 2.5, which is equal to 0.2. IN2 is equal to 0.0589. Similarly, case 3 also M is equal to 3.5 by 2.5, which is equal to 1.0, sorry 2.5 by 2.5. Why it is 2.5 by 2.5? Now, in this case of 3, in this case 3, these are 2 and 0.5, 2.5, and this case is your 1. So, then N is equal to 1 by 2.5, which is equal to 0.4. So, IN3 is equal to 0.1013. Then case 4, M is equal to, case 4, this case M is equal to 1.0 by 2.5 which is equal to 0.4, n is equal to 0.5 by 2.5 which is equal to 0.2, in 4 is equal to 0.0328. So, then delta sigma is equal to, you can put it in such a way that Q is equal to 80 into in1, in1 is your how much 0.1914 plus in2 is your 0.0589 plus in3 is your 0.1013, in4 is equal to 0.0328, which comes out to be 5.12 kilonewton per meter square. Are you getting this? Two examples. In this example, the load intensity is given 80 kilonewton per meter square, depth below the ground surface is your 2.5 meter. Now, this is the case. In this case, then it is outside the loaded area, this is actually the loaded area. Then I make in such a way that taking into point P, I make it so that it converts completely rectangular area. So, delta sigma is equal to Q into first this area, if I take complete this area inside and outside, this is the point P, then this area inside and outside, this is the point P, then this area, this is the point P. So, based on that, M and N has been calculated. You can always interchange M and N, you can always interchange M and N. So, case 1, M is equal to 2.5 and 1, it is your 3.5. So, 3.5 by your Z is equal to 2.5. I can write it as a N, I can also write it as a M, there is no problem. So, putting that formula you can get it, or you can take a chart, from that chart you can find it out In. Similarly, case 2, same case Mn and In2, case 3 Mn and In3, case 4 Mn and In4, then from there I got delta sigma. So, these are the two problems. So, these two problems supposed to be solved, you can take it. Another problem for you I am giving it. So, I will solve more problems later on. So, example 3, this is your example 3 and this point is your point P inside. So, this distance is point P from here, it is your 2 meter, here it is 3 meter, here it is 2 meter, here it is 2 meter. Now, if I take it, divide it in such a way that then this will be 1, 2, 3 and 4. So, for 1 all dimensions has been given, Q is given, Q is equal to 200 kilonewton per meter square and Z is given, distance below the ground surface is your 2.5 meter. So, you add it. So, what will happen, this is for your assignment, you can try simple one, sigma Z is equal to Q into In1 plus In2 plus In3 plus In4. Try it. For In1, what is your M? M is your 2 by 2.5. What is your N? N is 2 by 2.5. Then here for 2, it is again same 2 by 2. Here 4 it is 3 2. 3 is your 3 2. Find it out one by one. This is an assignment for this, then I will solve more problems maybe next class. Thank you.